Lesson 25. We are learning more derivative rules. So honestly, we're just kind of tacking on to what you guys already know about the derivatives. So it's taking that same rule and expanding it, in my opinion. Okay. One of the rules we're talking about is the constant multiple rule for derivatives. So basically, we talked about how to take the derivative of, say, x cubed, yes? Here, review. How do I take the derivative of x cubed? Okay. Move the 3 out front, and so then it's 3x, 3 minus 1 makes it 2, right? That's the derivative rule we already know. Now, the idea here is, okay, well, what do we do if there is a constant out front already? Okay, so in other words, instead of taking the derivative of x cubed, say, okay, what do we do if it's the derivative of 5x cubed?
Wouldn't you do the same thing, basically?
Yeah, exactly. That's all it is, but officially we're learning the rule here. So, and officially the way they show is if you're trying to take the derivative with a constant in front of it, you can just move the constant out front. Okay, so let me take you through it their way, but we'll just multiply them in the future. So they want us to take the derivative of 20x to the 15th. So I'm going to label as f prime of x. That's indicating it's a derivative. And so notation-wise, what we're going to do is the 20, we're going to think of separately. So it's the 20 here. And then what we're going to do is take the derivative of x to the 15th. Notation-wise, for the moment, d dx means to take the derivative of something with respect to x. So what this rule says is if you just hold the constant, so just we're holding on to the 20, and then we're taking the derivative of the variable part. So the derivative of x to the 15th. So if we hold the 20, what is the derivative of x to the 15th? You put the 15 out front, x, and then 15 becomes 15 minus 1, which is 14. And then the idea is you just clean it up. What is 20 times 15? So 300x to the 14th. Okay, so basic gist here. Basically, you're holding on to a number out front, and then whatever number you bring down out front to it, you also multiply by. Does that make sense what we did?
Yeah.
It's easier to just do it than it is for me to explain it. I'm struggling with how to explain it, so.
If I understand it, I'm sure everybody else is good with it.
Okay. Example 2, there's an A and a B. So f of x is given as 3x square root of 2. We're being asked to find f prime of x. Okay, so what do we do here?
Bring the square root of 2 to the front.
Okay, we're going to bring the square root of 2 to the front. The 3 is just going to stay out front. You're going to bring the square root of 2 out to the front. And then it's going to be what? X to the square root of 2 minus 1. What is square root of 2 minus 1? Yeah, I mean, we can come up with a decimal answer, but it'd have to be rounded and everything. So we're pretty much, about the only thing I can do here is put these initial pieces back together because I kind of put multiplication dots in there. But really, with this one, that's about all you can do because what is 3 times the square root of 2?
3 square root of 2.
So this is 3 square root of 2 x to the square root of 2 minus 1. Normally, I get it, we subtract those exponents, but on this one, we can't. So we're just going to leave it. Okay, B. G of x is negative 14, x to the negative 15th. So, I want the derivative, g prime of x. What do we do? Okay, we're already going to have negative 14 out at front. We're going to bring negative 15 out at front. X to the negative 16. You guys okay with negative 16? Because it's negative 15 minus 1, right? And so, clean this up. Negative 14 times negative 15. 210. X to the negative 16th. For one of my answers, I do have it left as such. 210 x to negative 16th. The answer key does often in calculus tend to leave it like this, not always so. What's the other way you could write this answer? 210 over x to the 16th, because that negative exponent would move to the denominator to make it positive. Questions on that part?
I think they're taking pictures.
Okay. I don't know if it's distracting you guys, but it's distracting me. So that's.
Let's open the door and throw something at them.
No, they might be done.
They just got quiet, so you're right. Maybe they're done. Let's hope. Okay, moving along. That was the first half of the derivative lesson today. The second half is how to take a derivative of a sum or a difference. Okay, so how to take the derivative when you have multiple things being added or subtracted. Now, I warned you guys, this is not a difficult lesson today. If you can do what we did there, that's all you have to be able to do.
Just do
Okay.
The back is kind of
Yeah. So,
Yeah.
don't worry about the back.
Okay, I'm not. I'm going to trust you.
Okay, do. Okay, guys. So, derivatives of sum and difference. Basically what it's saying here is if you have the derivative of two functions being added or subtracted together, all that means is you take the derivative of each function individually and then add or subtract those results together. Okay, so as you look here on this first example, there's 1, 2, 3 pieces, yes?
Yes.
You take the derivative of each piece individually and add and subtract the results together.
You're plugging each one of them in.
You're doing the derivative of, you're just doing each individual derivative.
So we're doing 3 derivatives.
Yes,
Oh my goodness.
but because there's 3 pieces.
I'm going to need to say a lot of space.
No.
No.
We're not using definition of derivative.
Are we basically? Oh, the short version?
Yes, the short version. The short version we just did up above.
Are we basically only doing 2?
We'll talk about that.
We're doing the short
Oh, that's next.
Okay.
The short version? I can't say. No, you weren't because it's short. Okay. Whew. I was like, oh no.
Same thing it was on the worksheet. It was show work. So, okay. Okay, guys, example 3 here. Find dy dx, that's saying find the derivative, where y equals 4x to the negative third minus 2x to the square root of 2 plus 4. So, in order to do this, first of all, dy dx equals, just worry about this right here. What is the derivative of 4x to the negative third? Okay, so if I was going to go in pieces, but I'm with you guys. There's the 4 here, yes. That negative 3 goes out front. So 4 times negative 3. And then x to the, what happens when you subtract 1 from negative 3? You're at negative 4. So by all means, if you went ahead and said negative 12, x to the negative 4th, I am all for that. You don't have to do these baby steps forever. Okay? I'm just trying to show you where the pieces are coming from. But by all means, I am fully fine if you go straight to that answer. Now what? Now we've got to do,
Negative 2x2.
okay, now it's the derivative of minus 2x to the square root of 2. So, the minus 2 is going to stay out front. Then what? Bring the square root of 2 down. X to the square root of 2 minus 1. And what is that square root of 2 minus 1? We don't know, so put this all together. It's minus 2 radical 2 x to the square root of 2 minus 1. And then lastly, the derivative of 4. Okay, so in order to take the derivative here, what is our variable? There is an invisible x to the 0. So if you need to think this way, and we will for the first one, okay, there's an invisible x to the 0. What happens if x is 0 when you bring that power out front? You're going to be multiplying by 0. And what is 0 times anything? 0. So the rule to learn here, they don't explicitly state it, but the derivative of a constant is always 0. In other words, I mean, if I'm writing it, I would write it plus 0, but do I need to write that in the answer? No. So my final answer is that negative 12x to the negative 4th minus 2 radical 2 x to the square root of 2 minus 1. It's a mouthful, but... So yeah, the rule to... I mean, basically, what are we doing? Every time we're taking an exponent and we are decreasing it by 1, yes? Well, then when you get to a constant, my exponent is 0. And so in that 0 times anything, you get a 0. Ready for the next one? Stop me as you have questions. Find f prime of x, where f of x equals 3 over x to the 4th minus 2x to the pi plus 2x over negative x to the negative 2 plus 4. Now, my recommendation, let's rewrite the original problem. Because are we going to take the derivative of 3 over x to the 4th as is? No, what do you think of that as? Yeah, you need to have just a regular, like, monomial there, where it's a number times a variable to a power. So, for the purposes of this problem, it's better to think 3x to the negative 4th. That next term is okay. Minus 2x to the pi. Plus, what about 2 over x to the negative 2? It'd be 2x to the positive 2. And that plus 4 is good. Now you ready to take a derivative? Okay. Can I skip baby steps here?
Yeah.
What is the derivative of 3x to the negative 4th? Negative 12x to the negative 5th. Are we okay with that? Multiply the negative 4 out front, you subtract 1. Okay? What is the derivative of minus 2x to the pi? What was it? Okay, that's where I was confused. Okay. Okay, so when you bring the pi out front, it was minus 2, so it's going to be minus 2 pi x to the pi minus 1. What's the derivative of 2x squared? Plus 4x. 4x is the first if you want, but 4x. And what's the derivative of 4? 0. So that term ceases to exist. How was that? The next one, it says let s equal negative 16t squared plus 42t. Find ds dt is what the statement should read. It doesn't ask you to find anything. You got left off. So find ds dt. So we're finding the derivative of s with respect to t.
does that mean with respect?
Okay, so find the derivative of s. This is the s equals equation. With respect to t, t is the variable we're going to be working with. Okay? So we'll talk about it more if we get to a point when there's x's and y's in a problem. Those kind of things. But okay. What do you know? Okay. Derivative of negative 16t squared. Wade says negative 32t. I brought the 2 down. 2 times negative 16. And 2 minus 1 is 1. Plus, what's the derivative of 42t? 42. Because what is my invisible power? It's a 1. 1 times 42 is 42. And then when you do 1 minus 1 in your power, 1 minus 1 is 0. And the 0 power on a variable, we just don't write that variable then. Because anything raised to 0 is always 1. Okay? And so that's why once you get t to the first, you subtract an exponent away, you're now down to just the constant. Questions there? Huh? Yeah, that's all you're doing there. Okay. The back side. All it does is it shows the proof of the derivative